Today's lesson is called the Binomial Theorem, or the Binomial Expansion. For our warm-up, I would like to take a look at multiplying a binomial times itself, x plus 2 quantity squared. And if you remember, we want to FOIL first, outer, inner, last whenever you multiply a binomial times a binomial. That's a shortcut. And x times x is x squared, 2x times 2x, sorry, 2x, 2 times x is 2x, plus the other 2x is 4x, and 2 times 2 is 4. Now what if we increase the power to a power of 3? So we have x plus 2 quantity cubed. So I'm going to take my solution from my first expression and multiply x plus 2 times it. So we have x plus 2, the first term distributes throughout, that's x cubed plus 4x squared plus 4x. And then we multiply the 2 times each term in the trinomial, and we have 2x squared plus 8x plus 8. And we need to combine like terms. So as you can see, I've lined these up so the common term, the like terms are on top of each other. Combined like terms, we get x cubed plus 6x squared plus 12x plus 8. What if we were to take it to x plus 2 to the 4th power? Well, this would continue to get more complex. And what if we took x plus 2 to the 10th power, 15th power, 20th power? What if we took it up to, who knows what? Well, fortunately, we have a formula for this because the expression always follows a certain pattern. And fortunately, this pattern is provided to us on the reference sheet on the New York Regents exam. It's called the Binomial Theorem. And here is a zoom up, and it looks like this. So we have a plus b to the nth power. We have n choose 0, first term to the nth power, b to the 0 power. And this pattern continues. We add this to n choose 1, so the 0 goes up to a 1, 2, 3 goes up to n, and the power of a decreases by 1, and the power of b increases by 1. So it starts off a to the n, b to the 0, and then the a power keeps going down, and the b power keeps going up until you end up with a to the 0, b to the n, and the n choose r, the r keeps increasing until we reach n. Okay, this can also be expressed as using sigma notation as r increases from 0 to n. Okay, so let's jump in and look at our warm-up example, x plus 2 to the 4th power, where a is x, b is 2, and our exponent n is 4. So following this pattern, we have n choose 0. So since n is 4, we have 4 choose 0. Okay, then we have a to the nth power, so that would be x to the 4th power, and b, which is 2, to the 0 power. And this pattern continues like this: n choose 1, so it's 4 choose 1, 4 choose 2, 4 choose 3, all the way up to 4 choose 4. We stop there because it stops here at n choose n. And over here we have x to the 4th power, and it diminishes by 1 each time it decreases by 1. So we have x to the 4th, x cubed, x squared, x to the 1st, all the way down to x to the 0 power. And b, the powers of b increase by 1, so we have 2 to the 0, 2 to the 1st power, 2nd power, 3rd power, 4th power. And as you can see, we are finished. So now we need to go through and actually evaluate these expressions. And just so you're not confused, I have expressed the binomial theorem vertically to save room. So I know that at the very end I'm going to add all of these up because these are all plus signs. 4 choose 0. Now we can actually plug this in the calculator. 4 choose 0 is 1. 4 choose 1 is 4. And here are the rest of them. Okay, 4 choose 4 is back to 1. We see we have a pattern 1, 4, 6, 4, 1. That's actually Pascal's triangle, and that's another lesson. So I've gone ahead and placed my coefficients 1, 4, 6, 4, 1 right here. Replaced these expressions with 1, 4, 6, 4, 1. X to the fourth, x cubed, x squared. I'm just going to go ahead and write those down. And anything to the 0 power is 1. Anything to the first power is itself. 2 squared is 4, 2 cubed is 8, and 2 to the fourth power is 16. And now we simply multiply. We get x to the fourth power, 8x cubed, 24x squared, 32x, and 16. And finally, we express this as a large binomial with plus signs between. X to the fourth plus 8x cubed plus 24x squared plus 32x plus 16. So this may seem like a lot of trouble, like we could have just gone ahead and distributed another x plus 2 throughout, but where it really helps you is when you have powers that are so high that it would just be inconvenient and not practical to do it the long way. You would use the binomial theorem. Let's take a look at this example. What is the fourth term in the expansion of y minus 1 to the 7th power? So first thing I'm going to do is define what is my a, what's my b, what's my n. So a is y, b is negative 1, and n is 7. And now I can go through and I can say 7 choose 0, 7 choose 1, 7 choose 2, all the way up to 7 choose 7, except we don't need to go that far because they're only asking for the fourth term. And this is the first term, second term, third term. Fourth term stops at 7 choose 3 because we started with 7 choose 0. And then here we have a is to the power of n, which is 7, and it decreases by 1. So we end up stopping at y to the fourth power. And b starts off at the 0th power, negative 1 to the 0 power, and it increases by 1 until we stop at negative 1 cubed. Putting all this together, 7 choose 3 is 35. Y to the fourth power, and negative 1 cubed is negative 1 because it's odd power of negative 1. So simplifying, we end up with negative 35 y to the fourth power. Number 3, what is the coefficient of the fourth term in the expansion of a minus 4b to the 9th power? A is a, that's easy. B is negative 4b. Notice that we need to make this negative because in the binomial theorem it's a plus b. So because it's minus 4b, this is actually a plus negative 4b. And n is 9. So since they want to know the fourth term, we only need to produce 4, concentrating on the fourth term of the expression in the expansion. So we have 9 choose 0, 9 choose 1, 9 choose 2, 9 choose 3. And here we have a to the 9th, 8th, 7th, 6th. And negative 4b starts at 0, 1, 2, 3. Notice how I keep negative 4b in parentheses because the negative 4 must be cubed. 9 choose 3 is 84. A to the 6th power. And negative 4b cubed, negative 4 times negative 4 times negative 4 is negative 64b cubed. And putting this all together, we have 84 times negative 64 is negative 5,376. A to the 6th b cubed. They only wanted to know the coefficient. So the answer is answer choice 1. It's negative 5,376. If you feel comfortable with the lesson, you can stop here. Here's a couple of Sage and Scribe examples. I'll just go very quickly and just show you the results. Fourth term is, as you can see, this one they actually never evaluated it. They just left it like this, 6 choose 3. What is the last term in the expansion? So you have to go all the way through the end, 5 choose 5. And we end up with 1 times negative 32, so the answer is negative 32. And finally, number 3, we have what is the third term in this expansion? A is 2x, b is negative 3, n is 5. And we end up with 720x cubed. And that concludes our lesson. Thank you for your attention. Best of luck to you.